So this is a video on how to draw shear force diagram and bending moment diagram. There are several methods we know, but this is one of the easiest method I would like to share. Now, the first step is that firstly find the reaction at this support. Okay, this is a pin support actually. It's supposed to have two reaction, vertical and what horizontal. But this horizontal will not be there because we don't have any horizontal force. So the horizontal force will be equal to what? Zero. The horizontal reaction here will be equal to zero. Just place the vertical one here also. So let me say this one is A and this one is what? Point B. So I'll say I have AY as my reaction here and I have BY. The first step is that find these reactions first. So I'll be doing it here. Before you can find this reaction, you're just going to employ what? Two equation. That is the moment at any of these supports. You can just say the moment at what? Let me say at B is equals to zero. And you can also say what? The summation of all the forces, the vertical forces must be equal to what? Zero. Now let's apply these two equations to get the reaction. Okay. Now I'm picking moment about this point. Remember, this one will create what? What type of what? Movement? Clockwise movement. So let me say my clockwise movement is equal to what? Like they are negative moments. So moment is this force. Let me do it here. This force AY times what is the distance from here to here? Distance is what? 2 plus 2 plus 2, and that's what? 6. So I'm putting negative clockwise moment. This one is anti-clockwise. You can say anti-clockwise. This type of anti-clockwise, anti-clockwise. So there'll be positive. So this 15 times distance from here to here, that's 4, plus 6 times distance from here to here, that's what? 2, equal to 0. I can bring this one here. If that minus 6AY come here, I have what? 6AY equal to, what would this one give me? So 15 times 4 plus 12, that will give me 72. So if I divide this one by 6, that will give me what? 12. So AY equal what? 12 kilonewton. So I have what? This is equals to 12 kilonewton. Now remember, the sum of forces Fy must be equal to 0. So the one going, I can say the one going up equal the one coming down. So I'll be having what? 12 plus By, those are the one going up, must be equal to the one coming down. 15 plus 6, that will give me what? That will give me 21. So my By will be equal to what? So I have 21 minus 12, that will give me what? 9 kilonewton. 9 kilonewton. So I've gotten the first step now. Now the second step is this. We just draw our shear force diagram directly. We will not, because one of the method I see most people doing that is very stressful is for us to be cutting the beam, and that will take a whole lot of time. But this video here, you don't have to learn how to cut any beam. You draw it directly. So let's go. Okay, so this is my shear force diagram now. So just observe the pattern. If you observe, I have 12 kilonewton being directed what? Upward. Check it out. 12 kilonewton being directed what? Upward. So I'll just go this way and just draw from here to here. This is my shear force diagram. Just draw a force, and this force is what? 12 kilonewton directed upward. Now, after you draw this one here, what's the next step? The next thing is that what? If you observe, from here to here, there is no force at all. This part is free. There is no force. So just draw like you're drawing constant velocity because there is no force around this side. So just draw a straight line. Good. Now, when you get here, there's a force that is pushing down. You know, this line here is what? 12, Abby. And this force is pushing down 15. So it's like you have 12 minus 15. And that will give you what? Minus 3. It means that this one will cross this line up to a point here, which is what? Minus 3 kilonewton. You can see 12 is going up, 15 is pushing it down. So to push it up to this point and also add 3 extra, and that's what? Minus 3 kilonewton. There is no force between this side and this side. That's free. So I'm going to be drawing it like this. No force. Now, when you get here, you have 6 again pressing it down. So you have minus 3 and another 6 again, minus 6 pressing it down. That will give me what? Minus 9. And that will give me what? Minus 9 kilonewton. So from here to here, no force at all. So you draw a straight line. You can see that where there is no force, I'm just drawing a constant line. Then after that, you can see that what? From here to here finally is minus 9. And here you are having plus 9, which is going upward. So it will go up and close it up to this point. You can see from here to here is minus 9, no force here, and this one is plus 9. So to close it up here. So this is my what? The shear force diagram. You can see very simple. Now let's draw the bending moment diagram. Now, one fact you need to know about this bending moment diagram is just one thing. Take note that what? The area under the shear force diagram will give me what? The bending moment. That's all. So what am I saying? Observe this diagram. Take note that what the moment about this point, take them as zero like this. Just pick them as what? This zero. Now let's draw. Take note that the area under the shear force diagram will give me the bending moment. So firstly, what is the area of this box you have here? This area of this box is a rectangle. So I have 12 times 2. Remember, 12 times 2, and that will give me what? 24. So I remember something, that this box here is above the x-axis, is positive. This one is negative, negative. This one is positive. So 12 times 2 will give me what? 24. So you are going to draw from this point. Just draw like this. So you have what? 24 kilonewton meter. That's the moment about this point. Next one, for you to get the next point, if you observe, the next box is this side you have here. And what's the moment? What's the area of this part? You have what? 3. Just say minus 3. Minus 3 times 2. And that's what? Minus 6. So I have 24. If I add minus 6, what will I have? So 24 minus 6, that will give me what? 18. So remember that this moment is below the x-axis. So it's going to fall. Are we together? It's going to fall like this. It's going to fall. It's going to fall to what? 18. I will explain that part again. Kilonewton meter. Check. The area of this one is 3 times 2, and that's 6. And it's a negative what moment. So if I add that negative to this, it will give me 18. And that 18 will slope downward. This is 24. 18 will come downward. Have you seen it? Now, the next one is this. What's the area of this point? You have what? 9. All this point is 9. 9 times 2 will give me what? 18. Have you now? And remember, it's a negative 18 also. So I have 18. Negative 18 will actually come to rest here as 0. And one thing again you need to know is this. If you see any line in your shear force diagram that is horizontal like this, take note that what? This one will be what? A line that will slope like this. Either like this or like this. Have you seen it now? You can see this straight line is above the x-axis. This one is rising. Below the x-axis falling. Below the x-axis falling. You can see the way I'm having it. That's that for that. Another thing you need to take note of is this. You can see that what? The point where the shear force diagram, cuts this x-axis. You can see this is where it's called this x-axis. That point is where you have your maximum bending moment. Those are the facts you need to take note of. The point where what? This shear force cuts this x-axis. That is the point where your shear force is 0. That is where you have your what? Maximum bending moment. Take note of that too.